Hey guys, how's it going? In this video, I'm going to go through this Leetcode 190 reverse bit. This problem was asked by Microsoft, Amazon, and Facebook in past 6 months. As you can see, this is not the most popular question on Leetcode, but I think it does give a very good foundation to solve other bit manipulation problems. Let's see what this is asking. As the name suggests, reverse bits of a given 32 bits unsigned integer. Let's look at an example over here. The 32 bits we are given looks like this, and we have to reverse it. So as you can see, the first bit that comes to the last position, second bit comes to the second from the last position. So after we reverse the whole thing, on the binary representation looks like this, and what we need to output is a decimal representation. But we have, in this exercise, we don't have to convert it. What we need to do is just reverse it. Okay. Second example, we are given a binary number looks like this. Just reverse it so the last number comes to the front, etc. Also, there's this constraint. We will use this constraint in solving our problem. So let's briefly walk through what we're gonna do. 32 bits bit too long for illustration. I'm gonna work on the 4 bits, and the same idea can be generalized to any number of bits in any size. So let's look at an example. Input we are given is 1101. So first we can do a AND operation. We can AND it with just 1. So we can put any zeros in front, right? We can just, in this case, we can put 3 zeros, and we can AND this one. So 1101 AND with 0001. So we can get the first bit at the rightmost bit, which is the first bit. Okay. And now, after we get the first bit, we just left shift the first bit to the front. But by how many units to do the left shift is by the bit size minus 1. So essentially, we are left shifting 1, 2, 3, 3 positions, which is equal to 4 minus 1. So in the case where if we are given a 32 bit size, we just left shift by 31. Okay, that's why I put it here, bit size minus 1. And then now our result, we can initialize our result to be 0, and we can do a OR operation. So essentially, if we do an OR operation with 0, so 1 0 0 0, right? This is basically 1 0 0 0. Okay, and with the OR operation, we can get 1 0 0 0. So basically, we can collect this bit on the leftmost position. So this is how we can work on the rightmost bit. And now we shift the input by 1 unit. So what we're going to get is going to be what we originally had was 1101. Now we have 110. And then we do the same thing, do the AND operation with 1. And then we again get the rightmost bit, which is in this case is going to be 0. And then we left shift by bit size minus 2. So we left shift by 2 units in this case. And then we do, so the result that we had in the last step is 1 0 0 0. And now we do the OR operation again. And what we get is going to be 1 0 0 0. Or we can just do a simple addition. It's the same idea. Not the same idea. We get the same result. And now after we get the first 2 bits, we can get the third bit again. So what we're going to do is just to right shift the input by 1 unit again. So originally from the last step we had 110, and now after we do the right shift, we got 11, and then we again do the AND operation. Sorry, the AND operation to get the rightmost bit. So that's what we get, and then we left shift by 1 unit. So we shift here to the one in here. So that's what we get, and then we do the OR operation again with the result that we saved in the last step. So now after we do the OR operation, what we get is 1010. Okay, and for the last bit, we again do the right shift again to get the final bit, and then do the same thing. So this is for the operation for a bit of size of 4. If we do like a 32 bits, we can do this like in 32 times, and then we could put it in the for loop. Let me show you the implementation in code. So we first have the result initialized as a 0, and power to be 31. So basically it's the bit size minus 1, and while the number that we did given is not 0, we first extract the rightmost bit. Essentially, we do the AND operation with the AND, right? So basically, this step over here, right? We're extracting the rightmost bit over here, over here, over here, and over here. And in the code implementation, it's going to be this line of code. And now we do the left shifting. By how much? By the power. Basically, remember, we are left shifting by the bit size minus 1, bit size minus 2, minus 3, minus 4. And this is exactly how we do it on the code. And then now we concatenate the result by using the OR operation, or we can simply just add to it. It doesn't really matter. And then after that, we just right shift the AND so that we can go through each one of the bits, right? So basically, remember, at the beginning of each step, we just do the right shift by 1 here and here, and this is exactly how we do it. And then we decrease the power by 1 for each of the operation, because here the left shift is decreased by 1. So let's submit that, and it works. It looks pretty efficient as well. So for time complexity, gonna be big O of 31. So that reduces the big O1. Basically, we just go through each one of the bits. And for space complexity, it's gonna be big O of n. Not big O of n, big O1 as well. Because we just have some result and some power in here and there. And yeah, and that's my solution to this problem. I hope you find this helpful. If it is, please consider like and subscribe. Thanks so much for watching. See you next one. Bye-bye.